In this video, we'll move into a new idea, criteria and conditional counting. We're going to start using Excel to ask specific targeted questions about our data and having Excel answer for us automatically. Now, we've already seen some formulas that let us aggregate our data, things like sum and average. There's also one called count. Like the sum and average functions, count takes in a range of values and it will count up all of the numbers in that given range. It can be useful if our range has blank values in it, otherwise it's just going to tell us how many total rows there are in our range. Conditional counting, on the other hand, is how we can count only those rows that match a condition that we actually care about, like how many orders are pending or how many priority orders missed their delivery date. These are the sorts of questions that keep a small business owner awake at night, and they're the kind of questions we'd like to have our spreadsheet answer for us, instantly, accurately, and without having to scroll. To start simple, let's first see the basic count function in action. For example, let's say we counted up all the values in column F. So you just pick any cell here and we say equals count from F to F. This kind of reference without row numbers says count all of this current column. So here we'll get the total number of records in our worksheet. So 127, and if we want to verify, we can scroll to the bottom and we can see that there are 128 rows, so -1 for the header. Now Countif works the same as count. We give it a range, and it counts it up, but in addition, we also supply what's known as a criteria. So suppose we wanted to know how many orders are currently pending in the order status column. So we could say Countif from G to G, and then we give it a criteria, which we'll say is pending. So criteria in Excel are simple tests that each cell needs to pass in order to be counted. Their syntax can be a bit interesting, but this one's pretty simple. Most of the time we're asking Excel, does this cell exactly match a given value? Here, for example, we're telling Excel to look through the order status column and count how many cells exactly match the word pending. And if we hit enter, we can learn that there are 40 pending orders in our datasheet. In this simple form of criteria, Excel can use any type of value and will count any values in our range which are equal to it. We can count how many transactions are for exactly 3 items in a similar way. Say equal Countif. The quantity is in the E column, so from E to E, how many of those have a 3? And we can see there are 22 orders of exactly 3 widgets. If we wanted to instead count how many transactions were for more than 3 items, we can use a comparison operator in our criteria as well. Equals Countif from E to E, and then in quotes, greater than 3. So notice I had to put this criteria in quotes. The reason for this is that a comparison operator is an operation, like a function call that's expected to be running a process. By putting in quotes here, we're giving Excel a way to take this information and pass it into the Countif function as an argument, which then uses it somehow to test each cell. The quotes turn a partial operation like greater than 3, which isn't a full comparison anyways, into a text string so that Excel can interpret it later on inside the process of Countif. Next, hard-coding a word like pending into our formulas, like we did up here, works for now, but it's not very flexible. A smarter approach is to let the user type what they want into a cell and then have the formula, our Countif formula, react to the value of that cell. So for example, over here in K2, we're going to type the word pending, and then we can change this formula to say, instead of just pending, just compare that to the cell we typed pending in. So we'll call this, put a bit of formatting here, we'll make this a thick outside border, and we'll call this call it the status key, which the user can type in then. So just like before, this Countif formula right here is counting all the cells in the column G that match exactly what's in the cell K2, which was pending. So we get the same answer when we hit enter. But if we change what's in cell K2 to say shipped instead, then our formula automatically updates and the count automatically changes. This seems like a small change, but it's a huge step towards making more dynamic, user-driven dashboards. We're hard-coding less and letting the sheet adjust to our needs on the fly. Let's put some labels on these just so we don't lose track of what these numbers mean. So this is count by status. Need to make our column bigger. This one was count quantity 3, and this was quantity greater than 3. Okay, so let's make another one here. Let's make things a little bit more interesting. Suppose instead of counting how many orders are pending, we want to count how many orders are not pending. So we'll change our status key here back to pending, and let's make a new one. So count by not status, and make that big too. And then over here we'll do another countif. So equals countif from G to G still, that's the status column. And now we want to say not pending. So we could say it like this, in quotes, not pending. So similar to how we said greater than 3, we had to put it all in quotes so that that criteria could be passed into the countif. We could do that like this as well. Now, this gives us a very big number, and that's because it's actually counting the entire column. Since we use the column reference G to G instead of saying G1 to G200 or wherever our data ends, it's going to count all of the values, and blank values don't equal the word pending, so they get counted as well. We could fix this by including row numbers in our range to limit where this formula is counting, but then we have to know that range, and if more data is added, it won't be included in this count. Instead, what we'll do is a bit of math and subtract all of the blank lines. So countif, the entire column G is not pending, minus all the ones that are blank. So we'll say countif from G to G again, and we'll say R equal to blank. So that's just 2 quotes with no text inside. If there's nothing in there, then it's a blank cell, and if it matches that, we're going to count it, and we're going to subtract all of those from our total count of not pendings. And that gives us a reasonable value. Now the issue here is that reasonable value is not going to change when we change our status key. If the user types in shipped, for example, that doesn't show us all the stuff that's not shipped because we've hard-coded pending into the formula. So let's go back to our formula here. We have G to G is not pending minus all the blanks. But if we want to combine the operator with a changing cell value like K2 here, then we also need to concatenate those two pieces of information together. Now the formula looks a bit odd, so I'm just going to type it first. It looks like this. Ampersand K2. Put some spaces so we can read it all. So the criteria says the not equal sign operator concatenated with whatever's in the cell K2. So the ampersand here is Excel's concatenation operator. Recall in Python we use the plus symbol to mean the same thing. Join these two pieces of text together. But notice here that the ampersand is not inside the quotes, which means it's going to be evaluated before we pass that into count. So the arguments to the concatenate operation are a string with the not equals operator and whatever the value of K2 is. So Excel will grab the value from K2, join these two values together, and pass that into countif as the criteria argument. So in this case, it will be not equal to pending. But if we change what's in K2, it'll be not equal to whatever is there. We hit enter, we end up with the same value. But if we change this to a different thing like shipped, then the value updates automatically. It can seem awkward at first, but criteria are a key Excel trick to building more flexible and reactive formulas. Now, since we're working with conditional logic here, and we've already seen how to do negation, let's now take a look at how to write OR and AND operations with Countifs. So, although we're allowed to write comparison operators into criteria, we can't just write functions and expect them to work. Okay, so since AND and OR are functions in Excel, that means they won't fit into a criteria, and we'll have to find another way to bring our values together. So let's start with ORs, because they end up being a little bit simpler. Sometimes we want to count anything from a range that matches this key or that key. For example, counting all of the orders from a customer named Antique or Barbed Wire. Although countif doesn't directly allow for an OR in its criteria, you can achieve the same effect by using two separate countif statements and adding their results. Right? If you think about counting all the values that equal key A or all the values that equal key B, the total should be the sum of counting all of one plus all of the other. So if we want to count all of the orders by Antique or Barbed Wire, so that's column B, we can say equals countif from B to B is the first person, so we'll call that Antique, plus countif again from B to B for the second value, and that would be Barbed Wire. So each countif handles one condition, and adding them together gives us the total. Next up, if we want to count rows that match multiple conditions at once, that is, if we want to use an AND condition, we use a slightly different formula called Countifs, emphasis on the S for plural. For instance, suppose we're interested in how many orders of mood bolts had quantities greater than 10. So how many orders We're for a product called mood bolts with a quantity greater than 10. We want both of those conditions to be true in order for our thing to be counted. Come over here and say countif and equals countifs. Notice there's an S at the end of the formula name. And the formula looks something like this. So the first range is for mood bolts. That's the product category, which is D to D. So we'd say D to D, that entire column. And then we could say equals mood bolts. And we could put our second criteria, which is the quantity, which is in column E, so from E to E. And we want to say is greater than 10. So greater than 10, all in quotes. So the arguments go range 1, criteria 1, range 2, criteria 2. And you can keep adding more ranges and criterias as you want as well. So here, column D is the product category, which must match the criteria text mood bolts. Here I put the equals operator inside the criteria just to be explicit, but if we had left it off, Excel would assume equals, just as we've already seen. Then E to E is the quantity ordered category, and that needs to match the criteria greater than 10. Both of these conditions need to be true in order for a row to be counted. We can add as many range or criteria pairs as we wish, and Excel will combine them all with an AND statement, meaning that all of them need to be true in order for a single value or a single row to be counted. Keep in mind that our ranges need to be the same length. This means that Excel can compare each row in one range with the corresponding row in the other range in a sort of one-to-one matching for every condition. If our ranges aren't the same length, then Excel will just respond with an error. And we got a 0, so let's just confirm that that's just bad data and not a bad formula. So here's a purchase for mood bolts with 4. Let's change that to a 14, and our countif changes to 1. So in this case, we actually counted something that didn't exist. So D to D must be mood bolts, and E to E is 10. There are a bunch of mood bolts, but it looks like they're all less than 10. No bulk orders of mood bolts here. Now sometimes we don't just want to count cells. We want to aggregate them with a sum or an average. But still, only those cells which pass a criteria. For this, Excel has SUMIF and AVERAGEIF formulas. For example, if we wanted to look closer at some of our customers, we could start by making another user entry cell. So we'll come over here and we'll call this the user key. So our target user here will be, one of the people in this list is named Terry Bull. And then we can use SUMIF and AVERAGEIF to see Terry Bull's spending habits. So for example, I'll say sum of user purchases. Let's make that big enough to see. I can go equals SUMIF. And SUMIF works similar to COUNTIF. We need to give it a range and a criteria. And we can see that in the prompt here. So here our criteria is going to be the user's name. So the range needs to be the column of names. So that's B to B. Next is the criteria. So the condition we're using to determine whether or not this cell is a match. So here we use the cell reference P2. So whatever's in that cell. And then lastly, we also need to include a range of values that actually get summed. Notice if we summed on the name category, that doesn't make sense, adding up a bunch of names. What's Terry Bull plus Terry Bull? Maybe super awful. I don't have a good pun there. So since that doesn't actually make sense, there's no way to add names together. What we're going to do is provide a separate range that anytime the value in our first range passes our criteria, we'll take the value from the second range and add it to our sum. So here we want to add up the amount spent. So every time Terry Bull shows up in the B column, we want to see what's the amount spent from the F column. So we're summing where B to B equals P2, we're going to sum the values from F to F. So if a cell from column B has the value Terry Bull, we'll add the number in that same row's column F to our running total. And if we want the average of user purchases, we can do that in a very similar way, equals AVERAGEIF from B to B, P2, and F to F. So again, like SUMIF, we need to give it the range for the criteria and the range that contains the numbers to be averaged. So you can see Terry Bull has spent a total of $735, but on average spends $190 per visit or per transaction. Criteria in SUMIF and AVERAGEIF have the same rules. They work the exact same way as they do for COUNTIF. It's the same idea, just different math at the end. And there's one last thing I'd like to show you about these criteria-based formulas. If you want to match patterns instead of exact text, Excel allows two simple wildcards that we can use in our criteria strings that will match with anything. If we use an asterisk, it will match any number of characters, 0 or more characters. And if we use a question mark, it will match exactly one character, but it can be any character. For example, if we wanted to count the transactions with customers whose names started with a J. So let's put that down here. Customers with J. So that's customers whose names start with J. We can say equals count if from the customer names category, so that's B to B. And then for our criteria, we could say J, and that will match people who are exactly J. But if we want to have starting with J, so J plus any number of other characters, 0 or more other characters, we can just put an asterisk in there. So J star says it needs to match that letter J, and that letter J needs to be at the beginning of the string, but whatever comes after that doesn't matter. It can be nothing, it could just be the letter J, or it could be Joe, or it can be Jim, or anything else. And if we hit enter, we can see that there are 8 transactions with customers with the name J. Note that's going to be counting people multiple times, so if Jim Socks shows up a few times, it's going to count Jim Socks each time. Perhaps a bit more practical, we can sum our total sales quantity of all widget type products using a wildcard as well. I'll say this, widget type sales. So I can say equals sum if, and we're going to count up based on the product category, so that's D to D. And now in this category, we have all different types of products. We have quantum widgets, we have wonder widgets, we have wooden widgets, we have wobble widgets, but then there are also products that aren't widget type products like portable black holes and pocket catapults. So we want to sum the quantity sold for just those products that are of the type widget. So that means our criteria is star widgets. So it can start with anything, but it has to end with the word widgets. In that case, we want to sum up the quantity, so that's E to E. We hit enter, and we've sold 196 total widgets. So this criteria would match quantum widgets, wood widgets, wonder widgets, and wobble widgets, which I believe are all the types of widgets that we carry. But similarly, if we just wanted to sum only the wonder and wobble widget numbers, we could use the other type of wildcard, the question mark. So we can say over here equals sum if, again from D to D, but now instead of saying asterisk widgets, for our criteria, we can put WO and then 4 question marks. So this will match the wonder and wobble widgets, which are both 6-letter type widgets starting with WO, but it won't match the wood widgets or the quantum widgets because those don't match this pattern. So this will match only products that start WO, then have 4 more letters, and then end with the word widgets. And we want to, again, sum their quantity, so from E to E. I'll call this the WO widget sales. So WO with 4 question mark wildcards. This criteria then matches any kind of 6-letter widget that starts with the letters WO. Maybe that's a bit of a niche scenario, but now you've seen how to use wildcards, and you can't unsee it. Now keep in mind that wildcards only work with text values, not numbers or dates, but still they're pretty powerful when you need to group data together or search through it with some fuzzy conditions. And that's about it for this video on Excel, Countifs, and related formulas. Now instead of scrolling through and manually counting our interesting data points, we can make Excel automatically pull answers that we need from thousands of rows of data in an instant. Save your work, don't forget to blink, and I'll be waiting in the next video.